Hi there, today we will talk about fuel cells and fuel cells here you can see this is the syllabus, batteries and fuel cells. We have finished most of these things here already, except it says, state the possible advantage of developing other types of cells, example, H2 and O2 fuel cells. So it's fuel cells here, and fuel cells is actually, so here, all right, this is actually the future cells. Nowadays, they want to have this green energy. And of course, this one here, the product is just water, and you get a lot of energy. And anytime, anywhere, as long as it's got oxygen, hydrogen, and your platinum electrodes, you'll be fine. So if the electric power goes down, die down, or whatever, you still have electricity. See? So your factory won't close down. This, in fact, is a future of cells. That's why platinum is going up in value. You need platinum in this lecture. Now, this is a general view of the fuel cells. Here is these two parts here. Okay, they are porous carbon electrode filled with platinum. Okay, so and platinum. So platinum is a key, right? Activated platinum here. So hydrogen, you have to make hydrogen, of course. So the point is, how do you generate hydrogen from water, whatever? So they say, oh, you get it from electrical energy. So you still go back to the idea of having fossil fuel in electrolysis. But there are other ways now to produce hydrogen. Okay, of course, oxygen gas here, two of them here. So oxygen gas and hydrogen gas are the main reactants here. Now here's electrolyte. Okay. They use it in space actually, and the space exploration, because oxygen and hydrogen is a gas they use for combustion as well as for breathing the oxygen, and of course in providing electricity. And the waste product is just water. You can actually drink it for themselves. So it's now here. Why is it the anode? Why is it negative here? Why is it positive here? We see it here now. Here to be specific, this is the real sort of view of the fuel cells. I got it from the net. You can see the oxygen here. Now, remember, electrons coming out from here. This negative pole here, positive pole. Remember, it's a cell, okay? It's a cell. Cell, that we know why is it negative, why is it positive. Now, to choose, the key thing is to choose properly the E0 values from the original fuel data booklet thing here. Now, put this down here. See now, hydrogen here. Now, how to get it from here? I can see from here, right? Now, this is a data booklet. You have to choose wisely. So all these things here, starting with silver here, blah, blah, blah. And of course, until here, you can see now there are two here called hydrogen. Hydrogen here, hydrogen here. Okay, so there are two electric potentials here now. So which one to choose one? Remember, it's either the condition is either acidic, which is here, it's on here, and of course, it's alkaline. So the right choice is important. Okay, that's why I cut these two and put down here. Right, these two here. See now, I cut so that you can see clearly. Okay, right. Hydrogen gas, I put it blue color so that it's easily distinguishable. Hydrogen gas and hydrogen gas. Okay. Right. Now this is of course your acidic medium. This is your alkaline medium. So the choice, which one to choose from, of course, depending on the type of electrode you want to put for your fuel cells. Same thing with oxygen. Same thing as here in oxygen here. Oxygen down, you go further down here. There are so many. There are 4 in fact. One more here if it's for alkalis. So the 4 here, now we have to choose one. So now here, oxygen here, oxygen here, oxygen here. So the choice is very important. That's why we give 1 mark for the choice of the equation. Okay. Now, of course, here is for acidic conditions. This is for alkaline conditions. Then so say there's one more here. But I also don't know what it's about. I know H2O, but HO2. So we don't care about this one here. Okay. Unless they give you the equation and tells you the conditions, and this is provided. So of course is to choose if it's acidic, if it's this one here, acidic. Okay, acidic. If it's alkaline, it will be this one here. So who to choose on is very important. That's why I put this 4 down here and I put it here so you can choose carefully. Okay, so now we talk about, in this case, the first one, of course, is alkaline fuel cell. That means this is alkaline, here's not alkaline. It can be NaOH or it can be KOH. Normally these are the 2 ones here. Of course, and it must be equals, N equals, of course, it be 1 mole per dm cube, 1 mole per dm cube, like you want to talk about standard condition. Cannot, right? E standard cell. Okay, it's what you want. Right, so now the choice is here. So if it's alkaline, it will be this one. Okay, and of course this one. Why? Alkaline and alkaline. So now, first of all, we choose the first, of course, the choice of E naught. So we have chosen, okay? Hydrogen is this one here, oxygen is one here. Now, then the poles, too, the poles. Okay, so original E naught value is negative. Why? Because it's negative here. And it's positive, okay? So negative, positive. So negative. So negative, that means this will be negative here, right? I put the red color. It's be negative here and positive here. So I chose the poles. Now, according to the poles, you connect a wire here, okay, to here. Of course, negative means what? A source of electrons, okay, of electrons. So it's coming out here, okay, and going down here. Which means if it's coming out here, it means here undergoes what? Undergoes what? Oxidation. Okay, here accept electrons, it means here will undergo what? Reduction. Okay, so this must be clear. So oxygen is the positive pole, hydrogen is the negative pole. So now it depends on how do you find the E cell. E cell, of course, is the easiest way. You go straight away for the E cell is E reduction minus E oxidation. Okay, so remember the E naught here must use the original E naught. So who is undergoing reduction? Remember here is going to here. So this is undergoing reduction, oxygen. Okay, right. So plus 0.4 minus 0.83. So the voltage is on here. But sometimes they ask you also for the overall equation, right? So in this case, you must see. So if it's negative pole is your hydrogen, okay? So you put negative pole here, so negative pole hydrogen, which means electron coming out, so oxidation. So oxidation we call anode, okay? Anodic oxidation, so it's always anode. So see, I reverse it, 2H2 plus O4OH minus 0. I use one here, but I reverse the equation. Okay, so this is going this way, is supplying electrons. These electrons will be the one coming out, okay, coming out to go from here to here. Electrons, okay. So I reverse it, and I must reverse the sign. So I say here positive 0.83. So under oxidation or oxygen here is receiving electrons, so it's receiving electrons, okay? So it's positive here. So as the received electrons, of course, is undergoing reduction here, okay? See, receive electrons. This is from where? From the hydrogen here, okay? So it's going this way, okay? So no problem, I put positive, okay? So I copy the whole equation down here, right? So it's positive here, okay? Very simple, okay? So of course, then the overall equation you hear, right? Now here I times by 2 because why? Here is 2 electrons. Here's 4 electrons. So to balance off the equation, I times by 2. So this becomes 4. I put blue color 4. This becomes 4 electrons. This becomes 2. This becomes 4. Okay. So this will balance off, right? So you add this two up, this one will cancel off this one here. Okay? This 4 here will cancel this one here. Right? Okay? All right. Okay, so this is the 2H, you put all this side here with 2H2, see now, so you put down here, 2, so this 4 here will cancel off. Okay, this will cancel off. Right? So this is 2 here, cancel off, this 4 even 2 here. So this is the over equation. Okay, right? Just get water. It means water is a byproduct of your oxidation of your fuel, and get this is the voltage. Okay, now this is under alkaline conditions. Okay, now let's look at now. Of course, you want to do the cell diagram this one, yeah, but this is no longer required in the syllabus, so don't care. Now there's a question here. Let me go straight to the question here, so you can easily identify this. Okay. Here, although the standard electrode potentials are measured for solutions with concentrations of 1 molar, right? This is the standard one. This is standard. Okay. Cells are used as sources of battery power to operate more than with more concentrated. They are asked why afterwards. Okay. This question concerns the electrode reactions involving the hydrogen-oxygen fuel cells. Okay, so we did already. So this is the main one here. In the hydrogen-oxygen fuel cell, H2 gas and O2 gas are fed into inert electrodes dipping into NaOH. Okay, so it's a very simplified version, right? So of the fuel cell. Don't get hydrogen here, oxygen here. Now here, very nice. Cambridge actually tells you what. See, the following reactions takes place, right? But if this is not given, how would you know? How would you know which one to choose from? Again, then you go back to your original thing here, right? Your original equations here. Okay, see here. Right. If you have to choose from, remember hydrogen, hydrogen. So under alkaline conditions, which is this one here. So you choose this equation. Okay. If it's oxygen, which is the one, of course, this one here, alkaline conditions of oxygen, alkaline conditions. Okay, choose one here. So these two are these are the choice. Now, Cambridge gives you the reaction that's actually happening. Okay, remember, after choosing the one, it says, well, which is negative, which is positive. Excuse me. Because it's negative here, so it's negative, it's positive. Okay, so it's moved from here to here. So it must be going backwards. See? Oxidation, that's why they give you the answer here. It's going backwards here. They write forward here. See here? See? H2 going here. Okay, now remember this is the original one here. You can see here. So it's going this way. Okay, so they tell you actually what's happening. So remember this, given electrons with oxidation. So of course you write the relevant, you just have to reverse this to give you a positive value here. Okay. Now for the right hand side, which is your oxygen here. Okay, you can copy the equation down here. It's the series here from your value. Okay. Okay. So here, right? So it's positive 0.4040 here. You can see from here. Okay, right? See, oxygen gas plus H2O. Okay, so here. Okay, so you just add up the equations here. Here they ask you for E cell. You can add up here and put the answer here. Or you can use what? You can use E cell goes to E reduction minus E oxidation. Okay, so you can see from here. Okay, reduction and so forth. But here you must use the original E0 values. Okay, so what's reduction of oxygen? Because this is the original one. Okay, so it's plus 0.40 minus oxidation is here minus 0.83. It will give you 1 plus 1.23. If you use the equation wise, also the same value here. So it's wiser to use this one because it asks you construct an equation. So you just add this one up. Remember now, okay? You can see if I put the blue color here, you can see it's very simple here. Here you get your 4 cancel off here times 2. Remember times 2. You want to make the 4 electrons here. Okay, 4 electrons here. So this one is 4, 2, 4, and here's 4, and it's 4. So this cancel off here. Right, this one cancel off here. Right, this 2 will cancel off this 2 here, so 2. So you get 2 H2 plus O2 gives you 2 H2O. Right, so here. Now for this tricky kind of questions here, by using one of the phrases more positive, more negative, or no change, deduce the effect of increasing the OH minus concentration in the electrode potential. Now here they mean the original one. No. So you must be very careful when you answer exam questions. You must always use the original E0 value to say if it's more positive or more negative or whatever. Okay, so I quote down for you here the 2 potentials for alkaline conditions. Okay, now, see here? Right now. These are original E0 values. Now, so if you increase, the whole idea is increase. You increase the OH minus concentration. So Le Chatter's will tell you for the first one here, I'm going to use red pen. Okay, so it will increase this one here, it will increase here to maybe 5 molar. Of course, it will go backwards now, right? If it go back, what happens to this? It becomes more negative, isn't it? Right? More negative. So it becomes more negative. Okay? Remember, backwards is negative, forward is positive. Right? Remember, this is for left-hand side is a hydrogen electrode. If you don't know which one here, put down here first. Okay, left-hand side, see? Left-hand side. This is your left-hand side. Left-hand side. This is your right-hand side. So go according to you're facing the paper here. Okay? Hydrogen. Right? So left-hand side. Okay? So here is oxygen. If we increase the OH minus, right? OH minus, what happens? It will shift backwards also. Right? If you shift backwards, that means what happens to origin? You know, it becomes less positive now. Right? Less positive. Less positive. Or I can say more negative. Now, of course, less positive is not here. See? Right? I know, but acceptable. See? Answer? Right? See the answer here? Becomes less positive or more negative. Either way. Because it's better to use less positive because of later here they ask you about the overall change. Okay? So more negative, less positive. Right? Okay? So here you can see hence deduce the overall E cell. Notice there's no more standard here because you want to increase the OH minus one. It's not 5 molar or 10 molar. Okay, whatever is it. So, right, hence deduce whether the overall E cell is like to increase, decrease, or remain the same. Right, when OH minus increases. Here. Now, look at here. I put down here so that I can easily, well, without any mistakes. Now, remember this equation is very important. So it's easy for you to argue out from here. So E cell is equals to E reduction minus E oxidation. Remember, reduction, of course, here is oxygen. Okay, right? It's electrons. So you see, it becomes less positive. Less positive, okay? It means the value becomes smaller. The value will decrease. Right? See, value will decrease here. Right? And the the left-hand side, which is your hydrogen here, becomes more negative, right? More negative, it means negative and negative. The value will increase there. So one decrease, one increase. So what happened? No change. Okay, so of course you cannot cover how much change, unless you use Nernst equation. So just put no change. The answer is no change. No change. Okay, so it's quite simple, right? So here, right? So suggest one other reason why NaOH concentration is high. Of course, easiest is to increase conductivity, okay? Increase conductance or lower cell resistance, increase rate reaction. But this is the most obvious one, increase conductance. So this is how they ask in exams for fuel cells. If it's alkaline conditions, they ask it for concentration effect. Okay. Now let's talk about the one which is your acid, which is simpler. Here now, of course, this is an acidic fuel cell. Same thing here, right? Come fill in, fill out the kind of thing here. Hey, this is our hydrogen. Hydrogen is here. Okay, hydrogen is here. Hydrogen is here. Oxygen is here. Put air, oxygen coming here. Okay. So and here's your acidic medium. So under acidic conditions. Again, you can see, well, which is the first, of course, to say which is the poles. Poles, you need to know, of course, the E, find the E original. Okay, so remember, now here I put out again, okay, hydrogen. Okay, now this acidic medium, this alkaline medium. Of course, you choose them now. Earlier, you choose the hydrogen, is it not? So this is the one here, 0. Now, for oxygen, again, which one to choose from? That means acidic. It's only one acid here, so choose one here. Okay, so now these two, now this is 0.00, this is 1 plus 1.23. So which is negative? Of course, this is negative, this is positive. So negative means what? Electrons are coming out. Negative means source of electrons. So come on here, electrons come here. That means this undergoes what? Oxidation. This undergoes what? Reduction. So remember, like right here, this is negative. This is positive. Okay, so some electrons come here. So that means, right, electrons will travel from here. So now so you want to calculate the E cell straight away, very simple. Use again this famous equation, E reduction minus E oxidation. So reduction, who is undergoing reduction? Okay, your oxygen here. Right now, reduction, see, plus electron, huh? Okay, so it's positive 1.23, right? Oxidation is, hydrogen is 0.00 because it's the standard relative thing. So it's again 1 plus 1.23. Okay, so very simple, isn't it? So the key thing is which electrode potential to choose from, because there's so many here, especially oxygen here. So look at the H plus and the OH minus, the conditions, and you choose them. And from there, you look at the sign, you can see the poles, and then you flow electrons, and then of course from there you can choose the correct equation, things like that. Now here, of course, you see this equation here, right? Right, for hydrogen, of course, oxidation here, negative oxidation. Okay, that's why it is called the anode. And this is the reduction here. Okay, right? So again, you can see it's 1.23. Doesn't matter what. Now there's a question here. It's a very simplified question. Okay, for an acidic fuel cell. Right? So the diagram shows the laboratory illustration of a simple hydrogen oxygen fuel cells. You can see oxygen here, atmosphere, which means the standard conditions. Okay, we don't care what kind of things here. Okay, this is basically platinum. Okay, this is HCl, see 1 molar. Okay, and here's hydrogen here. Again, this oxygen here, right? Also 1 molar. So this is the salt bridge. Okay, so write the half equation for the reaction occurring in the left. So the left is not oxygen, earlier was hydrogen. So remember, so which one to choose from? Okay, choose from quite simple here. Again, look at the oxygen. Okay, right? This is your hydrogen. This is your acidic medium. Okay, oxygen here, these two here. Okay, so these two are the choice. So which is the pole? So it's positive, negative. So remember, which means here, right? Electrons coming from here. This is your negative. Okay, this is your positive. Okay, right? So remember, here is undergoing oxidation. All these things put down in exam so that you look at it, you determine it, so it's easy for you to see. Okay, right? So here electron coming out. That means in this case here, half equation. That means H2 lose electrons in, right? So must put H2 here, H2. Okay, lose electrons. I mean H plus 2 plus 2 electrons. Okay, you can see from here, very simple. Right, the equation, the answer here. Sorry, they asked for oxygen. Okay, oxygen is plus electrons. Okay, so oxygen here, you choose from here. Okay, data booklet, very simple. Oxygen here. See, they didn't tell you no? Here, put blue color. Okay, okay, blue color here. So this one here. Okay. So O2 plus 2H plus 2E. Right? See, O2, you can see for the marking symbol O2, right? Plus 4E plus 4 electrons. Right? So you can see here the answer. Okay? Right? Okay. Of course, they ask you now, state the polarity of the left hand. Of course, you can know from the comparison. So it's positive. See? Positive here. So answer is positive. And ask you next one, of course, the data bullet use give the voltage very simple. You can use E cell. You can put down here E cell equals to E reduction minus E oxidation. Okay. Of course, reduction is who? Reduction, of course, is oxygen. Okay. The original is how much? Original one is how much is it? Original one reduction here. Plus 1, 2, 3. Okay, so it's plus 1, 2, 3 plus 1.23 minus, of course, minus is 0.004 hydrogen if it is acidic medium. Very simple here. You can see this one is, okay, acidic medium, right? So you get the same value as plus 1.23. Okay, say ignore the sign. Okay, so it's very simple. Once you know how to do it, it's very simple. Only a very small current is drawn from the thing here. So just one way you can modify to make the current more. Okay, so you can see here a bit of larger salt bridge, but basically this one here, the area, you increase the area of electrodes. That's why in now most modern factories, they actually build fuel cells now, because why green energy, well, everybody's going for green energy because the kind of economy is based on whether what's your carbon emission, things like that. So platinum is going up in price because of produce electrodes, okay, large area, or you can increase the concentration or the pressure of oxygen gas here. All right, so now this is all on fuel cells. We have covered all these things already. Okay, you can see here we have covered all these things. If you look at the syllabus, we have actually finished all on your cells. So the next one I'm going to produce, of course, is the one here called electrolysis. So because holidays, I'm only using half an hour. All right, so tomorrow I'll try to be not so lazy and make it 1 hour. Okay, electrolysis. Okay, so I'll see you tomorrow then. I want to see where to stop. Okay, stop recording. Bye-bye.